Hi folks, welcome back to Physics with Captain Rod. I'm making this video here to provide another example of calculating relative velocity and accelerations here. So we're going to take a look at number 201 on page 93. So let's see, it says to find the velocity and acceleration of A with respect to B. Alright, pardon me. Okay, so A with respect to B. We're going to start by looking at position vectors. And this vector right here, that would be the position of A with respect to B. Meaning, if you're in car B, where is car A? Now, if I take a look at a couple other vectors here, I'm going to just put a 0 here, and we'll call this position vector A. And here's position vector B. And the important thing is understanding the diagram. Of the three vectors that I have drawn, this one is the resultant vector because the other two are tip to tail. So we can write out that position vector A is equal to position vector B plus position A with respect to B. Now, this differentiates to then the velocity of A is equal to the velocity of B plus the velocity of A with respect to B. And I think that we know these things in the problem here. So let's see. Let's start with car B. Well, I'm sorry, no, we'll start with car A. A is traveling at 10 meters per second. I don't care about its acceleration right now. Now also, A is moving, let's see, 45 degrees like so from what I'm going to call the positive x-axis. So the velocity vector for car A can be written 10 cosine 45I minus 10 sine 45j. Now I'm going to go ahead and put the units last in this equation here. All right, now position equals velocity vector B, and that's simple enough. That's going to be 18.5I. No sines or cosines required, looking at that velocity vector. And then we're going to have plus velocity A with respect to B. That's all that's left. And now it's just a simple algebra problem to solve for velocity A with respect to B. We're going to have to just subtract this term. So that's going to equal 10 cosine 45 minus 18.5I minus 10 sine 45j. And these are in meter per second. I'll just put the units right here if you folks don't mind. Boom. Okay. Okay, now the accelerations. Now the acceleration is going to be a little trickier here because there's a little more going on, but starting right here, taking that equation, differentiating it, this is going to read acceleration of A is going to equal acceleration of B plus acceleration of A with respect to B. Now there's going to be a little more going on here. Okay, so car A has a couple of accelerations that we have to consider. I'll draw them individually here. One, it has a tangential acceleration equal to 2 meters per second because it says in the problem, oh, I'm sorry, car A is traveling at 10 meters per second and its speed is it's supposed to be increasing at 5 meters per second. So my bad. This is supposed to be a 5 here. All right, now, in addition to that, A is undergoing circular motion. So A also has a centripetal acceleration that points this way, equal to V squared over R. Now for car A, let's see, car A is traveling at 10 meters per second. It's a 100-meter radius. So that's going to be 10 squared over 100, which is going to come out to be 1 meter per second. Okay, now car B, let's see. car B has a tangential acceleration of 2 meters per second this way. And that's it, because car B is not right now undergoing any sort of circular motion. Okay, so we can now write out our relative acceleration relationships here. So the acceleration of car A, and first I'm going to deal with this vector. That's going to be 5 times the cosine of 45 degrees in the I direction. All right. Now we'll deal with this minus 1 times the cosine of 45 degrees. Again, these are both in the I direction. Okay, now J direction, both are down, so minus, going back to that first vector I dealt with, 5 times the sine of 45 degrees. That's for the y component of that vector right there. Oh, and how about we now put plus 1 times the sine of 45 degrees. And that's for the y component of this vector. Now that thing's y component is down, but you'll notice I have a minus sign right here. By the time it hits this, that's going to make that down. Okay, so, and that's in the j direction. So this entire thing, that's just the acceleration of car A in unit vector form. Okay, equals, right, acceleration of car B. Now B only has that 2 meters per second to the right. And that's it. And then the rest of this is plus acceleration of A with respect to B. Okay, there we go. Oops, I put the vector symbol in the wrong place. A with respect to B, vector symbol goes there. So now it's, again, it's just an algebra problem. Now I say algebra, it's still vector algebra though. You only add like terms. Oh, speaking of which, I forgot my unit vector on the acceleration of B. That was to the right, so that's in the I direction. There we go. All right, so acceleration of A with respect to B is going to be this minus this. So how about I absorb these and we call that 4 cosine 45 and then minus 2I minus 5, well, I guess we can just add these up, 5 sine 45 and 1 sine 45. I guess I see no reason not to just add those to 6 sine 45 J meter per second. I don't have a calculator handy, so I'm going to let you folks kind of clean that up, but there is the acceleration of A as seen from car B. I hope that this video helps you understand how to write equations to find relative velocities and accelerations. Have a great day.